Welcome to UGC EPG Pathshala. Hello, I am Dr. Shadab Khan, Assistant Professor, Crodimal College, Department of Geography, University of Delhi. I will talk to you about geomorphic hazards. We know that natural hazards are threatening events that can cause widespread damage to life and property. They have long-term consequences and their continuous impact can change or modify both physical and social space. In this section, we discuss the hazards that are intrinsically related to geomorphology as they are integral elements of our dynamic Earth. The endogenous geomorphic hazards like earthquakes and exogenous geomorphic hazards such as tsunamis, landslides and avalanches are discussed in detail. Let us first talk about earthquakes. For a greater detail, you can also refer to module on earthquakes. Earthquakes are some of the most devastating and destructive natural disaster experienced by any individual and the society. They occur without varying in different areas throughout the world. Earthquake can cause maximum damage and deaths in densely populated areas. Earthquakes are the result of vibration generated by sudden movement and rupture in the rocks that is being stressed beyond its elastic limits. These stresses can be natural or man-made. The intensity of an earthquake can vary from a faint tremor to wild shaking of the ground. Near the epicenter of the quake, the impact is direct, resulting in immediate damage such as collapse and destruction of buildings and other infrastructure. The area near epicenter then experiences secondary or indirect impacts such as fires and landslides. Earthquakes occur in a sequence of shocks. The largest earthquakes in a sequence is called as main shock. It is preceded by one of the more foreshocks and followed by aftershocks. The smaller earthquakes that occurs after the large one is designated as aftershocks. They are the result of the adjustment of fault plane formed by the displacement of the part of the earth crust after the occurrence of the main shock. Aftershocks are very dangerous because they are usually unpredictable, can be of large intensity. It can raise buildings to a ground already damaged by main shocks. We will now try to understand what are the causes of earthquakes. Earthquakes are mainly caused due to the disturbance of equilibrium in any part of the earth crust. Such happenings may be the result of diastrophic forces or sudden movements. It may sometimes be caused by expansion and contraction of surface area due to hydrostatic pressure produced by human-made reservoirs and water bodies. The theory of plate tectonics provides best possible explanation for the occurrence of earthquakes. Earth crust is made up of solid and moving plates. These plates can be oceanic or continental. For details on plate tectonics and earthquakes, you can see the modules on each of them. Volcanicity. Volcanic activity and earthquakes are intimately related to each other. They have cause and effect relationship with each other. The eruption of Krakatoa volcano in Sumatra produced severe earthquakes that are experienced 12,000 km away. Hydrostatic causes and anthropogenetic activities. Most prominent is reservoir-induced seismicity due to the disequilibrium in already isostatistically adjusted rocks below the reservoir. For example, the earthquakes of Koyna, Maharashtra, that was in Maharashtra in India, Hoover Dam in USA in 1936 and the Marathon Dam, Greece in 1931. Let us concentrate now on the earthquake hazards. Earthquakes are associated with variety of specific hazards. Some are characterized as primary hazards such as ground motion. When the seismic waves travels through populated area, ground motion is felt as shaking. The destruction linked to the ground motion depends upon the design and construction of buildings. Ground breaking. It includes wide opening in the ground due to the earthquakes. These ground breaks may have vertical, horizontal or combined displacement. Mass wasting. It may trigger the downhill movement of material lying on the slope. It can range from gradual creep to rolling of large blocks of rocks. Earthquakes may induce landslides and avalanches on steep slopes. Liquefaction. It is a process where sudden and intense vibration and shaking converts certain types of sands and muds into a slurry or a substance with a consistency of liquid. Changes in ground level. Due to earthquakes, sometimes blocks of earth shift relative to one another. It may lead to change in ground level, base level and water table. Other secondary and tertiary hazards associated with earthquakes are tsunamis, fires and explosion, displacement of people, loss of jobs and livelihood. Now, earthquake prediction and risk reduction is an important field so that adequate precautions may be taken against this hazard. It is very difficult to predict earthquakes. No definite means of predicting earthquakes are available. However, it can be predicted indirectly or by analyzing unusual animal behavior, studying hydrochemical pressures and increasing in turbidity. Seismic in many parts of the world are monitored using sensor, global positioning system, satellite technology. Earthquakes cannot be stopped, but risk can be reduced through preventive measures. These measures include building earthquake-proofs or resistant structure and safer homes, spreading awareness, conducting earthquake preparedness drills, and capacity building for emergency situations are some of the significant solutions. Another important geomorphic hazard is tsunami. Tsunami is a wave or a series of waves produced by sudden vertical displacement of the column of water. The displacement may be caused by seismic activity, volcanic eruption, and a landslide above or below water. Tsunami waves are sometimes also referred to as tidal waves due to its long wavelength. However, it is not related to the attraction of sun and moon. Tsunami waves are generated in oceans, bay, and other water bodies. The word tsunami comes from Japanese tsu and nami because it mainly affects coastal areas and harbors. In 1990, around 14 tsunami events occurred throughout the world. It did not cause much death and destruction, but tsunami of 26 December 2004 perturbed the entire world. It struck due to the largest underwater earthquake ever recorded off the coast of northern Indonesia. It generated devastating tsunami that swept the northern Indian Ocean and killed thousands of people who never anticipated such event. Let us understand what are the major causes of tsunami. Earthquakes. It is one of the common causes behind the origin of tsunami. Over 80% of all tsunamis occurred in Pacific Ocean were generated due to the seismic activities. When the earth crust is displaced by several meters during underwater earthquakes, it covers thousands of square kilometer area and induces tremendous potential energy to the water body. Tsunami can only be triggered by earthquakes that originating mainly in the upper 100 km of the oceanic crust. It has been found that earthquakes-induced tsunami is associated with the magnitude of 7 or greater on the Richter scale. Most tsunami-forming earthquakes are shallow foci or occur at a depth of 0 to 70 km. The greater the vertical displacement, the greater the amplitude of tsunami. Therefore, thrust fault associated with subduction zones are preferred mechanism for the generation of tsunami. Landslides. The topography along continental shelf and margins are often very steep, particularly near ocean trenches. Sediments lying over the continental shelf moves under gravity down the slope, generating marine landslides. It can form small to mega tsunamis whose magnitude may even surpass than those generated by earthquakes. The most notable example is Grand Bank tsunami in 1929. Volcanic eruptions. The contribution of volcanic eruptions in generation of tsunami is relatively lesser, around 4.6%, than seismic events and underwater landslides. Explosive volcanism with caldera formation can cause tsunami. It is mainly limited to a few areas such as Japanese Kuril Islands and Philippines and Indonesia's archipelagos. Comets and asteroids. Any asteroids and comet entering into the atmosphere at a shallow angle is more likely to reach the ocean without breaking, can create cavity that would be 10 times greater than the diameter of the objects. It can generate waves in different direction that may result into tsunami. Here, let us try to look at the mechanism and propagation of tsunami. When an earthquake struck undersea, the vertical displacement of sea floor also displaces overlying water. All the water rushes towards the points of displacement to fill the depression created by a down-thrown region. As a result, water recedes from the shore. Once the surface rocks are adjusted, all water rapidly moves towards the shore, forming tidal waves. If the sea floor is lifted up, then it will create a hill that would collapse eventually and sends waves traveling towards shore, leading to tsunami. In open sea, the tsunami waves propagates fast, low and long wavelengths, although they resemble similar to other waves of the sea. Tsunami travel across the open sea in a series of long waves with low crest. Tsunami does not lose energy during its travel to the shore. When tsunami reaches close to the shore, it enters shallow waters. It slows down. Portion of the wave closer to the coast or beach slow down, but its back maintains fast speed, forming higher and steeper waves. The tsunami produced by Krakatoa explosion caused tsunami with a wave height of 98 feet, that is around 30 meters. Now, I will highlight to you the hazards associated with tsunami. The regions where tsunami occur frequently are Pacific Ring of Fire, Mediterranean Sea, Caribbean region and Indian Ocean. The major hazards associated with tsunamis are now discussed. Inundation. Tsunami waves are able to push lot of water onto the shore, leading to floods-like situation. Destruction and damage to property. It destroys anything in its path, such as boats, buildings, houses, telephone lines and other infrastructure. Death and fatalities. One of the worst impacts of tsunami is loss of human life. December 2004, Indian Ocean tsunami caused death to 30,1974 people in Sri Lanka, 232 in Indonesia, 6,400 in India and 5,395 in Thailand. Fires and explosion. It causes damage to oil and natural gas storage and pipelines, resulting into intense fires and explosions. In Japan, due to tsunami of 2011, various oil tankers at ports and gas cylinders at industrial complexes were damaged and caused massive fire and explosions. Fukushima Daiichi nuclear power plant, 150 miles northeast of the Tokyo, was severely damaged by the earthquakes and tsunami, impairing its cooling system, resulting in a series of explosions, meltdowns and the world's worst nuclear accident in 25 years. Monetary loss, diseases and psychological problems. It also causes lot of monetary loss to individuals, family and government. The victim may also suffer from various diseases due to the stagnant water and decomposing dead bodies of humans and animals. Many people also tend to develop psychological problems after the event. I will discuss about all risk reduction in this section. The most important aspect of tsunami preparedness is its detection and early warning. Indian Ocean tsunami compelled world scientists to develop widespread tsunami warning system. The activities undertaken by the international community to develop early warning system are: number 1, seismic stations started collecting data on undersea earthquakes and transmit it to the monitoring centers such as Pacific Tsunami Warning System, that is PTWS, situated at Hawaii. Number 2, Tsunami Watch is released for regions which are going to be affected later by the tsunami events. Number 3, tide gauges were monitored to detect the changes in the waves. Number 4, US National Oceanic and Atmospheric Administration developed bottom pressure sensor to measure the wave characteristics and pressure changes. 5th, NOAA through DART. DART is basically Deep Ocean Assessment and Reporting of Tsunami, using sea surface buoys transit signals to satellite, which transfer data to shore-based regional warning system situated in Pacific and Indian Ocean. Other measures for risk reduction includes site planning and management, designating or zoning tsunami prone areas and change the land use accordingly, construction of structure and coastal homes at higher elevation, water breakers to minimize velocity of waves, construction of community halls and shelters. Another important geomorphic hazard is landslide. The term landslide describes wide variety of processes that results in the downward and outward movement of slope forming material includes rocks, soil, artificial fill or combination of these. The areas of world prone to landslides are mountain and hills, particularly deforested mountainside, areas with coarse grained soil or lack of vegetation. Several studies have shown that more than 12% of the land area of India is susceptible to landslides. The major landslide prone areas of India includes Western Ghats, that is in Nilgiri, and Konkan region in Tamil Nadu, Karnataka, Kerala, Maharashtra and Goa. Then Eastern Ghats including Arakan region of Andhra Pradesh, Eastern Himalaya that includes Darjeeling, Sikkim, Arunachal Pradesh, and Northwest Himalayas that includes your Uttarakhand, Himachal Pradesh and Jammu and Kashmir. Landslides have been declared as third most fatal disaster in the world. In world, around 300 people die every year due to landslides and around $400 billion are annually spent on landslide mitigation and disaster management. Let us now discuss the major types of landslides. Slides. It is a type of a mass movement where the sliding material detached or break from the underlying stable material. It can be divided into rotational slides and translational slides. In rotational slide, the movement is rotational and its axis is parallel to ground surface and traverse across the slide. Translational slide do not show any rotation. For example, block slides where single unit slides as a coherent mass. Falls. When rock, soil and debris break away from cliff and slope, they start moving suddenly. It may be the result of earthquake, weathering or gravity. Flows. It is divided into 5 basic categories that vary from each other in fundamental manner. Debris flow. Rapid mass movement of combination of loose soil, organic matter, water that flow downslope. Debris avalanche. It is a type of extremely rapid debris flow. Earth flow. It is mainly found in rocks that are primarily composed of clay and fine grained materials. The materials flow after liquefaction. In some cases, dry flow may also be possible. Mud flow. It is a type of earth flow where material is more saturated with water and contains half sand and remaining silt and clay sized particles. Mud flow and debris flow are also called mudslides. Creep. It is very slow movement. This caused by shear stress. There are 3 types of creeps: seasonal, continuous and progressive. Topples. It includes forward spinning and movement of huge masses of earth, debris and rock from a slope. It occurs when topples fails. Spread. That are little distinctive because it takes place on a very gentle slope or a flat terrain. It is caused by shear force or tensile fractures leading to lateral extensions. Now let us understand what are the causes of landslides earthquakes. It is linked with tectonic forces. It is a major contributor to the global landslides events. The 2011 earthquakes of Sikkim led to several landslides and mudslides. Climate. The most important component of climate is precipitation. Intense rainfall leads to ground saturation and increased in groundwater table that ultimately leads to soil runoff. Heavy rainfall, specifically in upper reaches of Himalaya, causes frequent landslides of this nature in Nepal, in Uttarakhand and in Himachal Pradesh. Weathering and erosion. Disintegration of rocks develops weak regolith that is more susceptible to landslides. Erosion wipes out lateral and latent support and facilitate landslides. Volcanic eruptions. It can also trigger landslides. If the eruption occurs and conditions are wet, the ash and mud coming out of the volcanoes may start flowing. Gravity. Steep slopes in combination with gravitational pull can cause massive landslides. Human interference. It also includes mining and excavation using blasting techniques, cutting and clearing of forest areas, construction of roads, land use and land cover changes, building reservoirs and water leakages from the reservoirs may also lead to landslides. After discussing about landslides, let us discuss landslide as a geomorphic hazard. Major landslides in the past have occurred in the Andes Mountain, Pacific Ring of Fire, tropical regions of Central America, Africa and Asia. Landslides hazards refer to the potential occurrence of a damaging landslides within a given area, such as damage could include loss of life or injury, property damage, social and economic disruption or environmental degradation. Loss of human life. In Ningxia, that is in China, in 1920, due to 8.5 magnitude earthquake caused 675 major Loess-linked landslide that killed more than 1 lakh people. In June 2013, mudslides in Kedarnath killed around 5,000 people. One of the worst tragedies took place in Malpa in Uttarakhand in August 1998, when nearly 380 people were killed due to massive landslides. This includes 60 pilgrims going to Mansarovar in Tibet. Discrimination of infrastructure and economic loss. It can cause serious damage to property. It can totally decimate roads, railway, telephone lines, buildings, homes and other infrastructure. The rehabilitation also involves heavy capital investment that puts extra burden on already cash-crushed states government in India. The risk reduction measures undertaken include hazard mapping and preparation of hazard zonation maps, afforestation and prevent deforestation, strengthening land use regulations, relocation of vulnerable settlements, retention walls and nets, strengthening of weak structures, drainage control measures and community education and awareness. In the last section, I shall draw your attention to another major geomorphic hazard, that is avalanches. Avalanches is a type of a slide which are amount of snow comes sliding down a mountain slope. It is also known as snow slide. The avalanche moving down slope when reaches bottom tends to gain power and speed, and this can transform a small slow slide into a full-blown disaster. What are the different types of avalanches? Avalanches can be categorized into two types on the basis of its depth. Surface avalanches that occur when a layer of dry but loosely packed snow slides over wet but dense layers of snow. Full depth avalanches that occurs when the full snow cover starts sliding. Avalanche can also be categorized on the basis of snow mass and snow type. Slab avalanche. When a plate of snow slides as a cohesive unit, the slabs are very huge in size. Loose snow avalanche. When snow that is loose slides downwards on a mountain slope. When loose slides are small in nature, they are termed as sloughs. Very few people are killed by sloughs. Ice fall avalanche. When glacier slides over a cliff and ice equivalent of a waterfall. Cornice fall avalanche. They are girdle-like snow structure formed by drifting of snow due to winds. The weight of falling cornice produces an avalanche on the slope, or cornice may break into pieces and transform into an avalanche. wet avalanche. They usually occur when warm air temperature cause water to seep in beneath the snowpack and reduces its strength. Glide avalanche. It is quite similar to glaciers. In this case, entire snowpack slowly slides as a unit and it is very slow process. Slush avalanches. They are unusual type because of its occurrence on gentle slopes. It mainly occurs in the permafrost soil that permits water to pile up and snowpacks get saturated. As a consequence, snowpacks loses its strength and slushes on a gentle plain. Let us look at factors causing avalanches. Terrain. It constitutes slope profile, angle of slope and ground surface. Slope ranging between 25 to 45 degree is prone to snow movement. The ruggedness and smoothness of surface rocks determines the pace of the movement of snow. Convex slopes allows more tension to develop, hence augments the chances of slab avalanche. Climate. Due to excessive snowfall, the snow buildup can be very rapid. It can create very unstable conditions. Sudden change in temperature, wind speed, direction may also influence stability of the snowpack. Himalayan region becomes vicious from January to March. Generally, winters with heavy snowfall are associated with major avalanches in Himalayas. Earthquakes. Himalaya is tectonically very active and any tremors or earthquakes can result in hazardous avalanches by breaking of large masses of snow, ice and rocks. Vibration or movement. Vibrations produced by vehicle coupled with the gravitational pull. It is one of the quickest way to cause an avalanche. The other is construction work done with explosives which tend to weaken the entire surrounding area. Human interaction. Human interference is the reason behind 90% of the avalanches. The avalanches area of India lies along the northern part of our country covering Jammu and Kashmir, Himachal Pradesh and the hills of Uttaranchal, extending up to Sikkim in the eastern region. The problem, however, is more acute in western part of the Himalayas where there is frequent interaction of troops and civilians with avalanches. Now, we will understand about the avalanche hazard. Major avalanches prone areas of the world are located in higher latitudes or subtropical regions of high altitudes mountain regions. They occur frequently in France, Swiss, German, Austrian and Italian parts of the Alps mountain. Other regions are Western Canada, Utah, Alaska, Colorado and Himalayan mountains. The major impact of avalanches are death and fatalities, damage to property, flash floods and economic impact. Lastly, we try to understand risk reduction and methods adopted for avalanche hazard mitigation. The agencies try to increase the general awareness of the affected population through preparation and publication of hazard maps and avalanche atlas. Secondly, training in avalanche safety and rescue methods would go a long way to bring down the avalanche casualties. In India, the Snow Avalanche Study Establishment, that is SASE says, has been forecasting and issuing warning for snow avalanches. This is mostly done for the movement of Indian Army in the glaciated region. SASE has been using satellite imageries, digital terrain model DTM, stress distribution model SDM for better forecasting. Some active methods have also been adopted in India to minimize the damage caused by avalanches. It includes structural control such as snow bridges, snow rakes and snow nets. Afforestation and artificial triggering method inhibits the disastrous buildup of snow cover on slopes.